Although it's not entirely necessary in this simple example of fitting the apoferritin data, simple constraints can be placed on the parameters to ensure that they stay within reasonable bounds. Often for more complex fits, these can be necessary to constrain the parameter values to things that you know are physically reasonable. To use simple constraints, click on the Use Constraints checkbox in the Curve Fit Setup window, and then on, say, the core radius, you can enter numerical values where you know the limits must be, like, say, a minimum of 30 angstroms and a maximum of 60 angstroms. And then when the data is fit, the fit will be constrained to within those values. In this case, we're already at the solution. We know it will end up correctly. And if there were any violations, these violations will be reported in the command window and say which constraint was violated and what the actual value was. If we want to apply more complex constraints to the system, we can do this using Igor's internal system for applying constraints, which is done in the sense of linear programming. That is, inequalities are allowed, that is greater than or less than, but no equalities are allowed. In this case, the simple relations of simple bounding constraints are applied in the sense that the core radius, lower limit, meaning core radius must be greater than 30, and its upper limit, core radius, must be less than 60. The internal variable system of Igor starts counting at 0. So the first parameter, the scale factor, is labeled K0. 0, and then through 1, 2, 3, 4, 5, 6 parameters. 7 parameters actually numbered 0 through 7 in this case. People count from 1, computers start counting at 0. Don't ask me why. So in this case, if you want to apply some fictional constraint that the that the core radius is twice that of the shell thickness, then we can apply constraints such that K1, or the second parameter here, is greater than 1.99 times second parameter, the shell thickness. And its upper limit is 2.01 times K2. In this way, it effectively pinches it in within a few percent of the actual equality, which is, of course, not allowed to be entered. You can pinch it in tighter if you like, or you can set up other known relations between the parameters. In this case, if we do the 1D fit now, with these constraints applied, it takes a few seconds to do the fit, and it does perfectly fine. The fit in this case, the chi-squared, is actually a little bit worse because it's somewhat of an unrealistic constraint, and in fact the constraints were not violated at all, because in fact if you take the shell thickness here of 21, multiply that by 1.99, you get 41.8 angstroms. So that no constraints were violated. And any of these constraints follow the rules here as outlined in the help file, and can help tailor these specific models and use as much information in the models as you know about your physical system. The more information you put in, the better and better physical interpretation there'll be in your actual results.